Tony's grandmother gave him a treasure box. The box has some silver and gold coins, and Tony is excited to see them. But the box has a number lock on it. Tony's grandmother told him that the number combination to open the lock is the number of silver coins followed by the number of gold coins in the box. But how will Tony know the number of coins without opening the box? So, Tony's grandmother gave him two clues. First clue is, the number of gold coins is one more than twice the number of silver coins. And the second clue is, the number of silver coins is 3 less than the number of gold coins. Can you help Tony open his treasure box by finding out the number of silver and gold coins? Let's say the number of gold coins be X, and the number of silver coins be Y. Now, using the first clue, we can write X equals 2Y plus 1 because the number of gold coins is 1 more than twice the number of silver coins. Next, using the second clue, we can write Y equals X minus 3 because the number of silver coins is 3 less than the number of gold coins. Both the equations are linear equations in two variables, X and Y. And so they are called a pair of linear equations in two variables. The solution of this pair of linear equations will tell us the number of gold and the silver coins which are in the box, which in turn will help Tony open his treasure box. Let's learn how to solve a pair of linear equations in two variables using graphical representation. Recall that an equation that can be expressed ax plus by plus c equal to 0 is called a linear equation in two variables where a and b are not both 0. For example, x minus 3y minus 1 equals 0 and 2x plus y minus 2 equals 0 are linear equations in two variables x and y. When we have two linear equations with the same variables x and y, we call them a pair of linear equations in two variables. The general form of linear equations in two variables is a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. In these linear equations, the coefficients are real numbers and the values of a1 and b1 as well as the values of a2 and b2 cannot be equal to 0 simultaneously. Do you know what a pair of linear equations in two variables represent geometrically? Recall that a linear equation in two variables represents a straight line. So, a pair of linear equations represents two straight lines or a pair of straight lines. Remember that these straight lines must be considered together, that is, as a pair. Now, for a pair of straight lines in a plane, there could be three possibilities. One possibility is that the two lines intersect at a point. The second possibility is that the two lines are parallel to each other. And the third possibility is that the two straight lines coincide with each other. These possibilities can be used to find the solution of a pair of linear equations. Let's find out how. A pair of intersecting lines has a unique solution. A pair of parallel lines has no solution, and a pair of coincident lines has infinite number of solutions. Let's go back to Tony's problem and find out how many gold and silver coins are there in the box. Let's first draw the graph for linear equation x equals 2y plus 1. For that, we need at least 2 points whose coordinates satisfy the equation x equals y plus 1. Let's take value of y as 0 and minus 1. We get corresponding values of x as 1 and minus 1. Plotting the points 1, 0 and minus 1, minus 1 and joining them, we get the line that represents the given equation. Next, on the same graph, let's draw the graph for second linear equation y equals x minus 3. Similarly, we take 2 points whose coordinates satisfy the equation y equals x minus 3. Let's take the values of x as 0 and 3. So, we get the corresponding values of y as minus 3 and 0. Plotting the points 0, minus 3 and 3, 0 and joining them, we get the line that represents the given equation. As you can see, the two lines intersect at a point with coordinates 5, 2. The point 5, 2 lies on both the lines given by x equals 2y plus 1 and y equals x minus 3. Hence, 5, 2 is a solution for both the equations. Since 5, 2 is the only common point that lies on both the linear equations, there is one and only one solution for the given pair of linear equations, that is, x equals 5 and y equals 2. Therefore, there are 5 gold coins and 2 silver coins in the box. And the number combination to open the lock is the number of silver coins followed by number of gold coins. Thus, Tony can open this box by using the number combination 25. Let's now see this situation. Tony wants to plant some plants row-wise in his field such that the number of rows equals 5 more than negative of twice the number of plants in a row, and 3 times the number of rows plus 6 times the number of plants in a row equals 15. Find the number of rows and the number of plants that he should plant in each row. Let's first express the given information algebraically. Let the number of rows be equal to x, and the number of plants in a row be equal to y. As per the first condition, we get the equation as x equals minus 2y. And as per the second condition, we get the equation as 3x plus 6y equals 15. First, we represent x equal to 5 minus 2y graphically. Let's take 2 points satisfying the equation x equals 5 minus 2y. Taking values of y as 0 and 1, we get x as 5 and 3. Plotting these points and joining them, we get a straight line representing the given equation. Next, we represent 3x plus 6y equal to 15 graphically. Similarly, we take up points satisfying the equation 3x plus 6y equals 15. Taking x as 1 and minus 1, we have y as 2 and 3 respectively. Plotting these points and joining them, we get a straight line representing the given equation. As you can see, both the lines coincide with each other. That means every solution of x equals 2y is also a solution of equation 3x plus 6y equals 15. Therefore, there are infinitely many solutions for the given pair of linear equations. Thus, we can say that Tony has infinite ways to choose the number of rows and the number of plants in each row. Seller went to a stationery shop to buy pencils and erasers. The shopkeeper gave her 2 combinations. 2 pencils for 10 rupees, or 4 pencils and 6 erasers for 12 rupees. Now, Seller is confused because she wants a single pencil and an eraser. Let's help her by finding the price of a single pencil and eraser. Let's first express the given information algebraically. Let the price of the pencil be x rupees and the price of the eraser be y rupees. The first combination gives the equation 2x plus 3y equal to 10. And the second combination gives us 4x plus 6y equal to 12. Let's find the solution of the pair of linear equations 2x plus 3y equal to 10 and 4x plus 6y equals 12. Let's draw the graph for both the linear equations by taking suitable points satisfying the given equations. Observe that the lines are parallel to each other and they never meet. Therefore, we say that the pair of linear equations does not have a solution. So Seller cannot determine the cost of individual pencil and erasers using these 2. We have seen that the graph represents intersecting incident. But can we do operations with red lines? Yes, we can. This is 1 by 1. Lines are intersecting lines. Therefore, this equations is unique. In the second example, and hence there are infinite lines are parallel to each other point. Therefore, pair of linear equations. The pair solution is called constants. That has no solution is called linear equations. The pair of linear equations, the infinitely many solutions, is a pair of linear. Now, let's compare the variables corresponding to establish the relation of equations. Pair of linear equations in general 1x plus b1y and a2x plus b2. Each pair of linear equations 1 over a2, 1 over b2, e1 over c2. Let's compare the ratios. In the first pair of linear equations are distinct pair lines and the solution. Next, in the second, all three ratios are equal. The lines are coincident line solutions for the pair of linear equations. And finally, equations, the ratios and b1 over b2, which in turn is not equal to the parallel lines, and there is no solutions. This means it is inconsistent. So, by comparison, we can find out the pair of equations and the equation.